Alrightly tidily folks, today's video is just some last little bits on the 4Runner that we did the first job when we got down here. The idle has been very, very high for quite some time, and when we figure out what it is, it's you know, obvious in hindsight, but it's quite humorous how long it took me to get there, actually. So why don't we just jump right in? We're back today with the 4Runner because things and reasons. This is the third body that this engine and trans have been in. Okay, actually the way that I met the owner of this vehicle was installing this engine 2 bodies ago at the shop I used to work at, funnily enough, in this town in Arizona. So it all comes full circle, I guess. The first body got into a wreck, bent the frame. He found another body, pulled the engine, put it in that one. The last body, they were off-roading, and they came down off of what they didn't know at the time was a cliff or some such thing, a hill with a fairly aggressive drop. And they were going too fast for the drop, and they hit the ground, and it bent the frame, it tweaked the arms, it messed up all kinds of stuff that would take a lot of time and effort to repair. So that one sat for a while. Eventually he found this body. He went up and grabbed it, took the V6 out of it. It had a rod knock, so the engine was bad anyway, and he stuck his 4-cylinder in it. And this is the second time he's done the you know, V6 to 4-cylinder conversion, as it were. It has been quite some time, and this engine has had a high idle problem. And I have been trying to diagnose it for the last month or so. There's a few different things on these engines that can cause high idle issues. In no particular order, one of them is timing. Incorrect timing can cause a high idle, too much advance. The O-ring on the idle adjust screw can go bad, actually, and cause the idle to increase. Usually that one is a small leak, so it doesn't do what this vehicle is doing. We checked it anyway, but this one idles warm somewhere around 1500, 1700 RPM. We don't have a tach that works. The one on the dash is non-functional. I've got to figure that out. But it idles very, very high. For a while, we had rotated the distributor to retard the timing a little bit so that we could bring the idle down, just so that we weren't sitting there revving the crap out of it, essentially, just as a test for a few days. I then decided to do a few things, a few tests, and we put the distributor roughly back. I haven't timed it yet, so that's a future thing, but we put the distributor roughly back where the mark was, where it sat for many, many years. Side story. So one of the diagnostic tests was retarding the timing and seeing if that did what it was supposed to do and bring the idle down. It does. It's probably not an ignition issue. Generally, ignition issues tend to cause lack of ignition, not early ignition. Anyway, not what we're talking about. Another thing that can cause high idle on these is a throttle position sensor being adjusted incorrectly or having failed. I did both Toyota's test on the TPS sensor and a test that I found in a forum. I should really find that. If I can find that, I will post that in a link in the description for you guys. Centralizing this information is kind of the reason why I'm doing this video. Because you look at forums and the information's scattered across hundreds of different forums, and it's sometimes a pain in the ass to find. So I want to consolidate all of the information. Okay, so we checked the TPS by the book, which is available various places across the internet. I don't have a link for you guys. I stumbled across it one day, and then I can't find it again. I don't know what happened to it. But they come and go all the time. So the factory service manual gives you a procedure for testing and adjusting the TPS, and I did that, and it was not maladjusted. It has never moved, as far as I know, from when Jasper built the engine 10, 12 years ago. And it is still adjusted correctly today. So that wasn't the issue. The next thing we checked was the idle control valve. Right, so this engine, the 22RE, from at least the 91 to 95 era, does not have an electronically controlled idle control valve. The idle control valve that is on this engine is just a fast idle valve. It's the same. It's exactly the same as Honda's fast idle valve for the DBHF series of engines, where when the coolant is cold, you have an open air passage. As the coolant warms up, the air passage closes a little bit and a little bit and a little bit until it's closed to a specific measured metering point. It never closes fully. It never closes 100%. But it's small enough of a, what do you call it? Small enough of a vacuum leak that it's accounted for by the programming in the computer, etc., etc. So we checked the idle control valve previously, and it was bleeding all the air. It was full open with the engine warm. You could stick your finger over it and the idle would go down. So that was a problem. So we replaced it. One common issue and complaint on these engines with the I call it the fast idle valve. The idle control valve is what Toyota calls it. Is that the very small coolant ports, hoses, and connections to the idle control valve tend to get gunk in them when people don't replace their coolant when you're supposed to, every 3 to 5 years, depending on the corrosion inhibitor design. Newer coolants are 5 years, long life, right? Older coolants tended to be 2 to 3 years replacement intervals. So when you don't do that, you end up beginning to develop corrosion inside the engine, especially in these with cast iron blocks, where you start to get rust, right? And rust particles will flake off the material, go through the system, and obviously the first place they go is tiny little ports and orifices where they just clog them up. I've seen plenty of posts and forums about people, they've replaced the idle control valve and it still doesn't work, and they pull it back off and they stick a pick or a small screwdriver or something of the sort down in the ports, in the intake manifold, in the hoses. They replace the hoses inside the control valve, whatever. They blow it out with air and chunks come out and it was clogged, and then it begins working. I checked that. The coolant flows through both hoses, so it's flowing in and it's flowing out. The idle control valve gets very, very warm at operating temperature, which tells me that if it were not getting coolant flow, it would not be as hot as it is because it sits on the intake. Intake flow alone would keep it cooler than the temperature that I am feeling. It's my hand, it's not measured, but it would be cooler than what it currently is. Also, when the engine is warm, there is a small vacuum leak, idle control valve port, which is normal. Whenever it's fully warm, it should be very, very little. I don't think they ever close fully, right? Another place that you can run into vacuum leak issues is this octopus's nest of vacuum hoses, right? These are all, so this one is vacuum, these two are ported. This one's ported, this one is ported, and it has been removed for testing. The octopus nest of vacuum lines, right? At least two of them are for emissions. One's for the EGR, one's for the charcoal canister. Another one is for the four-wheel drive system on the V6, which is not used on this vehicle, so we've disconnected it. Another point of failure on at least the 22 REs, with fuel injection especially, is the octopus nest of vacuums, because a few of them go to manifold vacuum and route that vacuum to various places. If the valve sticks open, it's a constant vacuum leak. If the valve body cracks, it's a constant vacuum leak. If a hose cracks, it's a constant vacuum leak, etc., etc. You can see where I'm going with this. I checked all of that. We did check all of the vacuum hoses. We checked the EGR. We checked the thermo switch down there. So we checked all the vacuum lines, and none of them caused a change in idle when we pinched them off, when we pulled them off and blocked them, when we sprayed them with brake cleaner to add an extra fuel source. Nothing. There does not appear to be any external leak causing the high idle. Okay, on to the next thing. You then have this idle up valve, which, as far as I could tell, this one actually is not functional. So this one is only being used currently for the power steering idle up. I haven't checked to see if it works. I don't know if it works or not, but these can fail inside, leaving that valve open completely at all times, which is a controlled vacuum leak specifically to idle the engine up when you apply a load at idle. So the AC or the power steering, either one, so that you don't kill the engine when you turn these devices on. Another thing we checked was the throttle linkage. There are reports of the linkage sticking. I imagine this is more prevalent on off-road vehicles more than it is street-only vehicles, but this linkage in here is known to stick a little bit. So we checked it, and you open it, you release it, and you see if it comes back, and then you press on it to try to return it manually, force it manually back to the 0 position. Doing that causes no change in idle, so it's not the linkage. We blocked off the EGR by putting a little aluminum shim in there. I made it bigger than it needed to be so that I could easily remove it in the future. But we put a little shim in there to block the airflow from the EGR, checking to see if the EGR valve was stuck in the open position. It happens, especially after this engine's only got 40 or 50,000 miles on it total. So I can't imagine that the EGR valve would be bad already and sticking. But it does happen on older vehicles, especially vehicles that use lower octane fuels, because you tend to get more carbon buildup on various parts with lower octane fuels, from what I can tell. That did nothing. I did also spray that sealing surface with brake cleaner just to see if I had introduced a leak, and the idle does not change at all when I spray it with brake cleaner, so it does not appear that it is leaking. The aluminum can is very, very thin, and it's a graphite gasket, which means it can sort of reshape itself a little bit. So it's the thing is sealed, it is not leaking, and the idle is still high. At this point, I'm starting to run out of ideas. Then I started thinking, well, what if it's the airflow meter? There's a test for the airflow meter. I did some basic checks on it previously, and it was the basic checks that I did, the first 2 or 3 checks from the book. Everything was fine, and if the other checks were wrong, the engine wouldn't run. I pulled the coil and igniter out, took them down to Joe Riley's so that we could test the igniter, because O'Reilly's has an igniter tester, and they don't even have a listing or a connector to hook the thing up to their ignition system tester. It's another one of those parts where if the ignition was bad, you would lose spark. It shouldn't cause an increase in idle. So it's like I said, I was running out of ideas. Then I thought to myself, well, intake valves sticking open could cause high idle and lack of power. Possibly. Not very likely, but possibly. So I checked the valve adjustment. 3 of the valves were a teeny bit tighter than they should have been, and he's never done the valve adjustment. You're supposed to do it and he's never done it. Again, the engine only has 40 or 50,000 miles on it at this point, so it's not crazy overdue, but it was slightly overdue. The valves, 3 of the valves were out of adjustment. The rest of them were fine. Good thing about these engines is their reliability, because they don't wear very quickly, other than the timing covers. Timing covers are a whole different thing. That's a whole other video. We're not even getting into it. So back to out of ideas time. I checked the secondary air injection system. It has been completely bypassed. Okay, there can't be any vacuum leaks there. It's not even connected. I checked the throttle body gasket again, and the plenum gasket again, and the manifold gasket where it meets to the head again, and still no leaks. I checked all of the valves again, still no leaks. I checked to see if maybe we were adding extra fuel because the cold start injector was stuck open, which would not cause a high idle, it would cause a lower idle. But again, I was out of ideas. Nothing. So last night, I decided I'd do something. I was gonna do another test. I had one last idea, but I wanted to check something else first, just in case. My one last idea was, because the engine has been replaced, and I wasn't here, I have no idea if grounds were connected, if a ground wire broke and somebody just didn't notice, something like that. So an idea I had was, what if there was a weak ground? If it was no ground, the engine very likely would not run at all. But if it was a weak ground and there was a small potential difference, the ECU would not be receiving the right numbers from the sensors. Intake temperature sensor, throttle position sensor, etc., etc. It would think that it was trying to run higher than it really is, something like that, right? So I was like, okay, well, I'm going to grab the voltometer and I'm going to check for a potential difference between the engine, the body, the battery. And I was going to check the ECU case also, just to see if maybe something had happened to the ECU because it had a hard hit, and who knows if somebody kicked it when they fell, or something was in the cab that hit the ECU case and caused a small short that did not fry the board but caused all kinds of funny issues. So I popped the hood yesterday and I got my trusty voltometer out and I set it to the side, and I wanted to check this one last thing. I wanted to see if the issue was being caused from an external vacuum leak or not. That was my question. So let me grab the tools, start the engine, and show you guys what I did and what I found. already know right now what somebody's going to say. They're going to say, well, of course it shuts off. You're taking the intake off, and the engine can't run without the flow meter. I know that. Keep watching. What I am doing here is I am holding the flow meter open so that obviously the intake temperature sensor isn't going to be reading 100% correctly, but it's still inside the engine bay, so it should be fine for temporary testing. Obviously, it's not going to severely change anything. The flow meter door must be opened some distance before the fuel pump turns on. If I let the door close, the engine will shut off, which we'll show you here in a minute. But I also stuck my finger in the door hinge to hold it in place to maintain the same position where it was when I pulled the tube off and the air was still flowing through the flow meter, right? That tells the engine, well, it tells the computer, keeping the door at the same position tells the computer how much air is flowing into the engine, so it can tell the injectors how long to stay open to fuel correctly, right? What I have done is I've used this little piece of closed cell foam. I can't breathe through it, which means the engine can't breathe through it either. I have completely blocked off the idle control valve, the low temperature fast idle valve, right? The thing that is controlled by the coolant. So I have blocked him completely. The idle set screw is also bottomed out. So without air flowing through the idle set orifice and without air flowing through the fast idle orifice, where exactly is the air coming from? So I did this test first, right? I was like, wait a minute. How does this make any sense? Air's got to be getting into the engine from somewhere. Okay, well, it's got to be from an external source then, some vacuum leak on the intake that I just simply have not found. I have literally spent 2 cans of brake cleaner spraying this thing down, and there's nothing. There's not a single thing. So, what I discovered was I took my little piece of closed cell foam and I stuck it in kind of sideways. And lo and behold, on the side where the linkage sits, we hear the idle go down. This tells me that the edges of the throttle blade are leaking and that the throttle blade itself is smaller than the bore of the throttle body. We've been looking for throttle bodies and have not been able to find any for a reasonable price. Everybody wants $300 for these throttle bodies. So we'll keep looking. Technically, the first thing I did to determine if it was an external leak or an internal leak was this. And you can see as soon as I start to get vacuum on my hand and it pulls my hand towards the throttle body, the engine tries to shut off. Right? If it were an external vacuum leak big enough to cause this high of an idle, I should be able to almost completely block off the throttle and the engine could still run. Probably not well, probably not at a very high RPM, but it would still have enough air to idle a little bit. I also promised you guys I'd show you what happens when you let go. Obviously, if you don't have the intake tube hooked up, you can't turn the fuel pump on, so you lose fuel. But if your airflow meter comes disconnected, or you lose air tube and your engine shuts off, that's all it is. That's all it takes, is this door closing. And I don't know, we'll see if we can hear it. So I'm going to put my finger in here, and I will push the door. Listen to the fuel rail real quick. The airflow meter controls the fuel pump, which pretty much everybody in this community knows that, but anybody who's just getting into it, anybody who's brand new and fresh, and this is their first 4Runner and they fell in love with it and they want to fix it, but this has problems, that is a little piece of very, very useful information, that the airflow meter turns your fuel pump on. We look inside and we can see a couple of different orifices. The big one there on the bottom is for the fast idle valve, or the idle control valve. The small one there on the side, you can follow it straight outside, and right there, that's your idle set screw. It just bleeds air from in front of the throttle body straight around to behind the throttle body, or throttle blade, I should say. There's also another orifice over here, which is for the breather system. Right? So we follow that orifice, we come out, it comes up here to this tube and goes to the breather. That is the filtered air into the crankcase for the positive crankcase ventilation system. Because if you have vacuum on the crankcase, you can cause seal issues. So you don't want vacuum on your crankcase necessarily, but neither do you want positive pressure on your crankcase. Positive pressure can cause the seals to just blow straight out of the holes. So we don't want either one of those. We want to kind of keep it roughly 1 atmosphere. Ideally, you want it a little bit less than 1 atmosphere, so that you're actively sucking vapors out of the crankcase. Ideally, you're sucking vapors out that contain burnt oil and combustion particulates, but it doesn't really happen that way. But we checked this also, the breather. We just took and plugged it. But that doesn't do anything because it's pre-throttle blade. It's on the filter side, which means it's not a vacuum leak. It can't be a vacuum leak. This hose cannot be a vacuum leak. This, however, goes directly to manifold vacuum. It can be a vacuum leak. We plugged him. That's the PCV valve, positive crankcase ventilation. We plugged the PCV. The idle did not change. And all of that led me to the foam test. You can try to stick your finger up against the throttle blade in there and try to seal it. Your finger's not the right shape and it's not soft enough, and because there is coolant actively running through a part of the throttle body is very, very warm. So it's not very comfortable to try to stick your hand in there. So we had a little piece of foam in the back from an old package. I ripped the foam out, I stuck it in there, and there is quite a bit of air bleeding around the throttle blade. So there is lateral play in there. Oh yeah. And there is axial play in there, which I guess axial is that and lateral is that. So yes, there is play in that whole system. There's far more play than I think reasonably there should be. Moral of the story is he needs a new throttle body. This one is very, very, very worn, and everything we find on eBay seems to be $300. So we'll keep our eyes out, and I hope you guys will leave a comment down below if you find something.
And remember, if you liked this video, it brought you any kind of value or helped you in any way, don't forget to like it, subscribe it, crank it, and rip it. And we'll see you in the next one.